My name is David Layzell, and I want to talk to you today about Canadian energy systems. In the developing world, our energy systems have fueled a very high quality of life, delivering luxuries that would be the envy of virtually all previous generations. These systems have also brought with them some unintended consequences, including air pollution, water contamination, and climate change. The global scale of the climate change issue and its frightening environmental and economic implications has focused attention on our need to transform our energy systems and dramatically reduce the greenhouse gas emissions that are the byproducts of fossil fuel combustion. This diagram represents the energy systems of Canada in 2010. In it, the thickness of each of the lines is proportional to the amount of energy that is actually flowing through that part of the system. On the left, we have the primary sources of energy that are made available in Canada or imported from abroad. Canadian energy industries recover and process these energy sources into crude oil or into energy commodities that include gasoline and diesel fuel, electricity, and ethanol. These energy commodities are either exported or used to meet the domestic demand for energy services. Now, Canada is very unusual among developed nations of the world in that we are a major energy exporter. We send more than 50% of the primary energy that we extract from nature to other countries, primarily the United States. Today, I want to talk to you about our domestic energy systems. I'm going to simplify this diagram by removing the exports and the imports and focus only on the energy flows that are used to meet our domestic demand for energy services. As in the previous diagram, Canada's energy industries convert the primary sources of energy into energy commodities to meet the domestic demand for non-energy uses such as plastics or paints and other materials that use both oil and gas. For personal mobility, and actually our supply chain, our movement of goods around, we use primarily oil. Almost 100% of the energy input is from oil. Our residences, where we live, as well as the buildings that we have, our commercial and institutional buildings across Canada, are reliant on gas and electricity, not so much on oil. And then our non-energy industries, including mining, manufacturing, etc., tap into all the sources of energy that are part of Canada's energy system. So where do the energy-based greenhouse gas emissions arise within this system? As you can see here, they're associated with the places where energy is converted, either into different forms of energy, as I've talked about before within the energy industry, the white areas, the white bars, or into energy services on the right-hand side. What I want you to note is that about 2/3 of the domestic emissions in Canada from our energy system, or 336 million tons per year, take place where we consume the energy commodities to fill service demands. Power generation and the recovery and processing of oil and gas make up most of the remaining 33%. So as a society, we need to decide how best to transform our domestic energy systems to dramatically reduce their greenhouse gas emissions, even by as much as 65 to 80%. Achieving this transition will not be simple, and many argue that we don't really yet have all of the necessary technologies. However, this kind of systems-level perspective that I'm showing here makes it possible to identify some high-level features of an energy system transformation that are needed if we are going to address the concerns about climate change. And I have 3 of these items on my list in the remaining couple minutes. The first is to recognize the very important role that electricity must play in the future clean energy systems. Electricity is the only energy commodity, the major energy commodity we have, that does not produce an emission at its end point of use. So it's ideal for use in meeting distributed energy demand. However, we first must eliminate the fossil fuel emissions associated with power generation and replace it with some of Canada's vast hydro, wind, solar, biomass, and nuclear resources. We also need to expand capacity of our electrical systems with additional clean energy to achieve major emission reductions, both on the demand side of our energy system and on the supply side. And indeed, if the yellow arrow going back, showing electricity flow to our supply side, some of the most promising transformative technologies for reducing emissions from oil and gas production require large supplies of low or zero carbon electricity. The second key element for energy system transformation involves technology and social innovation. There is much that can be done to enhance conversion efficiency or to deliver the services we demand with less energy or at least lower emissions. Transforming urban design is imperative since cities are where most of the majority of the demand emissions occur on the right-hand side of the diagram. What we need are energy systems technologies that not only reduce the environmental footprint, but are less expensive and more convenient. We need for energy what digital technologies did for the music, photography, movie, and book sectors in the past 20 years. So that's our key element number 2. The final key element number 3 is about the resources that will make this happen. And to finance this transformation, we certainly need a price for carbon, but I personally don't think this will be enough. We are fortunate in Canada to have a second option, to couple the economic benefits of fossil fuel energy and export to the transformation of our domestic energy systems. We know that the lack of access to global markets is depressing oil and gas production in North America. What if we were to link the public license for companies to extract and export Canada's energy resources to activities within Canada that will make us the global leader in the transformation to sustainable domestic energy systems? Our vast resources are in an energy-hungry world offer us this opportunity. Thank you.